Okay, so let's talk about hydrated ionic compounds. When ionic compounds crystallize from a water solution with water molecules incorporated into their crystal structure, we call it a hydrate. Hydrates have a specific number of water molecules chemically bonded to each formula unit. A chemist may know the formula of the ionic part of the hydrate, but not how many water molecules are present for each formula unit. Let's look at an example here. We have Epsom salt, which consists of crystals of magnesium sulfate heptahydrate. Okay, so this right here is the magnesium sulfate, and this is hepta, which is 7 prefix, and heptahydrate, okay, which there are 7 water molecules. Okay, every formula unit of magnesium sulfate has 7 molecules of water weakly bonded to it. Okay, so 7 water molecules are weakly bonded to the magnesium sulfate. A raised dot in a chemical formula in front of one or more water molecules denotes a hydrated compound. Note that the dot does not include multiplication, but rather a weak bond between an ionic compound and one or more water molecules. Compounds that have no water molecules incorporated into them are called anhydrous, to distinguish them from their hydrated forms. Okay. For example, a chemist might refer to CaSO4 as anhydrous calcium sulfate because there is no water present. Okay, so let's look at a problem here. A 3.34 gram sample of a hydrate has the formula SRS2O3. We don't know the number of molecules here, so we're just going to represent X. Okay, so we're going to replace X since we don't know the actual number of the water molecules that's present in this hydrate. Okay, so the hydrate has the formula of SRS2O3, okay, X H2O, and contains 2.30 grams of SRS2O3. Find the value of X. Okay, so we're just basically finding this part right here. Okay, so first we will start off by finding the moles of SRS2O3. Okay, so moles of SRS2O3, which is equals to mass of SRS2O3 over molar mass of SRS2O3. So the mass of SRS2O3 is 2.30 grams. Okay, so we're just going to write this at the top here. And the molar mass of SRS2O3 can be found using the periodic table. Okay, so the molar mass of just SR right here would be 87. Okay, so 87.62 grams per mole. Okay, and there's only one atom of SR. Okay, plus there are 2 sulfur atoms, so we're just going to put 2 in front of it, and the molar mass of sulfur is 32.07 grams per mole. Okay, plus there are 3 atoms, so we're going to write 3 in front of it, and the molar mass of the atom, okay, is 16 grams per mole. Again, these numbers right here can be found on the periodic table. Okay, so once you add all of these up, you will get 199.76 grams per mole. Okay, so let me just simplify this here. So it will be 2.30 grams over 199.76 grams over moles. Okay, so the grams get cancelled out, and then all you just have to do is 2.30 divided by 199.76, which you will get 0.01151 moles of SrS2O3. Okay, so that will be our first step of finding the answer. Okay, so the second step would be to find the moles of H2O. Okay, so we would have to find the moles of H2O. Okay, which again is equal to mass of water over the molar mass of water. Okay. However, in the question, the mass of water is not specifically given. However, we know the sample of the hydrate, which is 3.34 grams, and we also know the mass of the SrS2O3, which is 2.30. So if you find the difference between these two values, we're now able to find the mass of H2O. Okay, so it will be 3.34 grams minus 2.30 grams over the molar mass of H2O. Again, H2O, there are 2 hydrogens and 1 oxygen. Okay, so you put 2 in front of it, and the molar mass of just 1 hydrogen is 1.01 grams per mole. Okay, plus mass of molar mass of 1 oxygen, which is just 16 grams per mole. Again, these values can be found in your periodic table. Okay, so next you would just find the difference between here, 3.34 grams minus 2.30 grams. That will give you 1.04 grams. Okay, and once you add these two up right here, the molar mass, which is 2 times 1.01 grams per mole plus 1 times 16 grams per mole, that will give you a value of 18.02 grams per mole. Okay, so you write that value at the bottom here, grams per mole. So again, grams get cancelled out, and all you just have to do is 1.04 divided by 18.02, and that would give you a moles of 0.05771 moles of H2O. Okay, so we were not able to find the moles of H2O and also the moles of SrS2O3. Now the third step to this solution is to find the ratio of between SrS2O3 and H2O. Okay, so we would just find the moles ratio of SrS2O3 and the moles of H2O. Okay, so the mole of SRS2O3 is 0.01151, and the moles of H2O, which would be 0.05771. Okay, so when finding the ratio, we would divide it by the lowest ratio. Okay, so 0.01151 is lower than 0.05771. Okay, so we're just going to divide this by 0.01151, which is the lowest, and we do the same thing to the other side. 151. So 0.01151 over 0.01151 just gives us 1. Okay, 0.05771 over 0.01151, that gives us 5. Okay, so there are 1 mole of molecule of SRS2O3, and there's 5 molecules of H2O. Okay, so therefore the value of X, the value of X is equals to 5. Okay, so the final answer would be SRS2O3 5H2O. Okay.